أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا. طبعا مادة الديناميكا هي مادة علم الحركة. طبعا الدرس بعنوان البكرات البسيطة. والبكرات البسيطة طبعا مبنية على تطبيقات على قوانين نيوتن. وقوانين نيوتن دي مهمة جدا جدا، عملت طفرة كبيرة جدا في حياتنا العملية. طبعا القانون الأول بيقول إن الجسم يستطيع أن يحتفظ بحالته من حالة السكون أو الحركة ما لم تؤثر عليه قوة خارجية. والقانون الثالث مهم جدا برضو، ولكن بيقول لكل جسم أو لكل فعل له رد فعل مساوي له في المقدار ومضاد له في الاتجاه. Welcome my dear student in our math program for in secondary 3. Today we are taking new lesson in dynamic. It's titled Simple Pauli. My dear student, look at Simple Pauli introduction. Look at my dear student, Simple Pauli. My dear student, motion of system of two mass hanging vertically from the end of string passing over smooth Pauli. My dear student, the motion of a system of two mass hanging vertically from the end of string passing over a smooth or a smooth Pauli. Look at my dear student. Example. The two mass M1 and M2 gram, such as M1 more than M2, are tied at two ends of a light string passing over smooth Pauli. If the system moves vertically with an acceleration 196 centimeter per second square, what is the required? The ratio between two mass M1 ratio M2. Look at the solution. My dear student, we have two mass. Look at in the opposite figure, we have two mass M1 and M2, such as, my dear student, M1 more than M2. The weight of M1, M1G. The weight of M2, M2G. What is the G? Gravity force, 9.8. Then, my dear student, this Pauli, we have two tension are equals. Since M1 more than M2, the first equation, my dear student, M1G minus T equals M1A. Remember, my dear student, G is 9.8 or gravity force, but A is acceleration, T is tension. This equation number 1. The motion is vertically down. Why? Because M1 more than M2. The second equation, T minus M2G equals M2A. My dear student, we have two equations in unknown. G is unknown? No, 9.8. A is no, 196. T is unknown, tension. Also M1 and M2. My dear student, look at the two equations. How to solve the two equations? Excellent student, we adding the two equations. Why? When you add, you simplify the tension, then find the value or the sum. By adding equation 1 and equation 2, we get M1G minus M2G equals M1A plus M2A. By taking highest common factor, therefore G multiply M1 minus M2 equals A multiply M1 plus M2. G equal 980 multiply bracket contains M1 minus M2 equals A 196. Remember, my dear student, acceleration A 196 centimeter per second square, but G equal 980 centimeter per second. Look at, my dear student, what is the ratio? To find the ratio, then find 5m1 minus m1, therefore 4m1 equals 6m2, m1 over m2, 6 over 4, divided each term by 2, answer is 3 over 2, then the ratio between m1 and m2 equals 3 over 2, or m1 equals 3 over 2 m2, or 1.5 m2. Then the ratio between m1 and m2 equals 3 ratio 2. Another example. My dear student, two mass of 175 grams are tied at the two ends of string passing over fixed smooth Pauli. The system is kept at rest where the two parts of string are vertical and the two mass are in same horizontal level. The system is left to move from rest. What is the required? Find acceleration and the velocity of each of two mass after 3 seconds from starting motion, and find the pressure of the Pauli. Solution. My dear student, look at in the opposite figure, we have two mass 175, then the motion is vertically downward. The first equation, m1g minus t equals m1a. This equation number 1. Second equation, t minus m2g equals m2a. By substitution about m1, m2, then we know that m1g minus m2g equal m1a plus m2a. Take highest common factor, left hand side g, right hand side a. Then, my dear student, we deduce that acceleration is 180 multiply bracket contains 100 minus 75 over 100 plus 75 inside bracket equals 140 centimeter per second square. This is acceleration A. What is the velocity? Use V equal V naught plus AT or V equal U plus AT. Remember, my dear student, U initial velocity or V naught. Then V naught equals 0. Start from rest by using acceleration after 3 seconds. Acceleration is 140 times 3, then the velocity equal 420 centimeter per second. From equation 2, we know that T equals M2 multiply bracket contains G plus A. Then the value of the tension T, 75 multiply 980 plus 140 over 980 to find the value of T with weight, gram weight, 600 over 7 gram weight. What is the pressure? In this case, the pressure of the Pauli equal to tension, to T. By substitution about T equals 600 over 7, then the pressure of the Pauli equal 1200 over 7 gram weight. Now we are translate to another example. My dear student, two bodies of mass M1 and M2 gram, such as M1 more than M2 kilogram, are connected with a string passing over a smooth Pauli. They are on the same height from the ground. As beginning motion after 1 second, The vertical distance between the two bodies is 20 centimeter. What is the required, my dear student? Find the ratio between two mass, M1 and M2. Look at the solution. My dear student, we have two mass M1 more than M2. The first equation from first mass M1G minus T equals M1A. Remember, the motion is vertically downward. Why? Because M1 more than M2. This equation number 1. What is equation number 2? T minus M2G equals M2A. Therefore, my dear students, by using addition, we reduce that G multiply bracket contains M1 minus M2 equals bracket contains M1 plus M2 times acceleration A. Therefore, my dear student, find the acceleration by G multiply M1 minus M2 over M1 plus M2. We know that G equals 9.8 or 980 centimeter per second. This is gravity force. My dear student, by substitution about M1 minus M2, then find the distance. We know that the distance or the second rule of motion S equal V naught T or UT plus half AT square. What is the U? Initial velocity. What is the A? Acceleration. Or the T is time. S is distance. We know the distance between two mass is 10. U equals 0. Then find the value of acceleration by substitution is 20 centimeter per second square. This acceleration of motion of the system of the two mass. Then we know that if the distance between the two mass is 10, acceleration is 20 centimeter per second square. My dear student, from equation 3, by substitution to find the value of M1 and M2. You know that G, 980. After we find the acceleration A, 20, then M1 minus M2 over M1 plus M2 equals 20 over 980, or by simplify equals 1 over 49. By using cross multiplication, my dear student, 1 over 49 equals M1 minus M2 over M1 plus M2. Therefore, my dear student, the ratio between M1 and M2 equals what? 50 over 48 divided by 2 equals 25 over 24. This is the ratio between the two mass. Don't forget, my dear student, the ratio became 25 ratio 24. My dear student, smooth Pauli or smooth Pauli. We have two mass, M1 more than M2. Then the motion must be with M1. Why? M1 more than M2. The first equation, M1G minus T equals M1A. The second equation starts from T. Why? Because the motion is up. T minus M2G equal M2A. My dear student, now we are starting to another example. Two scale pans, each is of mass 105 grams. They are connected at the two ends of a light string passing over smooth Pauli, where the two scales hang vertically. In one of them of body, one of mass 350 grams is put and in the other scale, a body of mass 420 gram is put. My dear student, we have two bands. The first, we bought mass 350 gram. And in other scale, a body of mass 420 gram. Then M2 more than M1. My dear student, what is the required acceleration of the system? The number one. Number two, pressure of each of the two scales in gram weight. Solution. My dear student, look at, we have two bands. The first is 420 gram. The second is 350 gram. The motion must be with 420. Why? Because more than the second. Then we deduce that the equation of motion 525 gram minus t equals 525 A. The second, t minus 455 gram equal 455 A. Then find the value of A equals 70 centimeter per second square. My dear student, look at 420. What is the reaction of R1? We know that M2G minus R1 equals M2A. My dear student, R1 by simplify equals M2 multiply bracket G minus A. Find the value of R1 by substitution. R1 equals 420 multiply 980 minus 70 over 980 equals 390 gram weight. F350, what is the reaction of the 350 weight? By using the same equation, R2 minus M2G equals M2A. Then R2 equals M2 multiply G plus A. By substitution, then R2 equals 375 gram weight. Now we are translate to another example. Two bodies of mass M and 700 gram. One unknown and one known. Two bodies of mass M and 700 gram, where M more than 700, or the first mass more than the second mass. Two masses are connected as the two ends of a light string passing over smooth pauli, such that the two parts of string are vertical. The system starts motion from rest. The pressure on the pauli 800 gram weight. Find the value of M. Solution. My dear student, look at the two equations. We know that 700 gram minus T equals 700 A. Then by substitution about gram and about A and about tension to find the value of A. Then we deduce that acceleration is 420 centimeter per second square. My dear student, 2T equals what? 800. Then the tension of each is 400 gram weight. By using the tension minus mg equals ma to find the value of m. Then, my dear student, by substitution, then 400 times 980 minus m times 980 equals m times 420. Then, my dear student, value of m by simplify equals 280 gram. Another example. Two mass 5m and 2m are connected at the two ends of a light string passing over smooth Pauli. Are connected at the two ends of a light string passing over smooth Pauli. The system is kept in equilibrium when the two parts of string are vertically. The system is left to move from rest. What is the required? Find the acceleration of the system, the value of A, if the pressure on the Pauli axis equals 112 Newton. Then find the value of mass, M. My dear student, look at solution. We have two mass 5m and 2m. The first equation 5g minus t equal 5ma. Then the second motion t minus 2mg equal 5ma. My dear student, the first equation 5mg minus t equal 5ma. Second equation t minus 2mg equals 2ma. My dear student, look at the two equations. 5mg minus t equal 5ma. Second equation t minus 2mg equals 2ma. By using addition, then 3mg equals 3ma. By simplify each term or divided each term by m. Find the value of A. Then 3 times 9.8 equals 7a. 9.8 gravity force. Therefore, A equals 4.2 centimeter per second square. This is the value of acceleration. Then, my dear student, 5m times 9.8 minus 56 equal 5m times 4.2. What is the value of m? My dear student, m equals 2 kilogram. Then the value of m equals 2 kilogram. Look at another example. Look at, my dear student, a light string passing over a Pauli fixed vertically carries at one of its ends of mass 60 gram, and at the other end it carries two mass 40 and 50 gram. If the system starts motion from rest, find the acceleration motion if the body of mass 50 separated after 2 seconds from starting motion. Then prove that the system will be at rest instantly after 2 seconds from the moment of separating the body. Solution. My dear student, look at the opposite figure. We have two mass 40 and 50, it's some 90 gram. The motion vertically down. The first equation 90 gram minus t equals 98. Second equation t minus 60 gram equals 68. By using addition to find the value of acceleration. Then acceleration, my dear student, equal 3 times 980 over 150 equals 196 centimeter per second square. this acceleration of motion. My dear student, if we have one is separated, this motion 40 gram minus t dash equal 40 a dash. T dash minus 60 gram equals 60 a dash. Also by using addition to find acceleration after separated, then a dash equal negative 196 centimeter per second square. Then, my dear student, we use the first equation of motion, velocity, final velocity equal initial velocity plus e dash t. By substitution, v equals 0, initial velocity 492, and acceleration negative 196 to find the value of the time t. Then t equal 2 seconds. Dear student, by the end of the lesson, we know that smooth Pauli or smooth Pauli very important answer in dynamic. Very important lesson in dynamic is smooth Pauli. My dear student, by the end of the lesson, I am very too happy to spend such time with you. Thank you. Goodbye.